I'm doing this video on stationary or standing waves, and I'll just introduce to what stationary and standing waves are. We have talked about waves in general. So, for example, if we have a wave going in this direction, right? This type of a wave which is going in this direction is known as a plane progressive wave. It could be a transverse wave or it could be a longitudinal wave. It is called a plane progressive wave because it's progressive, meaning that it is moving ahead, right? It's progressing, it's traveling in this particular direction. It's called a plane wave because it's moving in two dimensions, right? It is moving, the wave is traveling in this direction, whereas the particles are going up and down in this direction. The moment is in two planes, and hence it's called a plane progressive wave. In the previous video, we also talked about what happens when a wave travels in a bounded medium. Say, for example, this is a bounded medium, this is a closed boundary, and a wave travels in this direction. What happens is this wave encounters this boundary, and then gets reflected and starts moving back, right, in the same direction. If we study this closely, what happens is this particular wave which is traveling in this direction, let us call it the incident wave. And the wave which gets reflected back from this boundary, right, let us call it the reflected wave. So we have an incident wave going in this direction and we have a reflected wave going in this direction. They are traveling in the same medium, therefore what happens is they superimpose onto each other. Right? So we have a situation where one wave is traveling in this direction and the reflected wave is traveling in the opposite direction, and these two superimpose onto each other. The other fact is that these two waves are identical. They're exactly identical, meaning they have the same amplitude, right? The wave amplitude is same, the frequency is same. So these two waves are exactly identical. Also, they're traveling with the same speed. Now, when this happens, what we observe is that a new type of wave is produced, right? A new type of wave is produced. Right? And this particular new type of wave which is produced is stationary in nature. Right? Stationary in nature, meaning that if you look at this particular wave, right, it will give you a feeling or give an impression that the wave is not progressing, it's stationary. Meaning that if you look at this particular wave, right, what you will observe is that at these particular points, the wave is stationary, and this particular part goes up and down. For example, this wave is going in this direction. There's a wave which is coming back in this direction, and if you look at this particular wave, it will give you the impression as if the wave is stationary. Meaning that this particular particle, if I focus my attention on this particle will go over here, then it will come over here. Right? This particle will go, maximum displacement for this particle is this much, it will come here and it will oscillate back and forth between these 2 points. This particle will move like this, up and down. This particle is stationary. Again, this particle will go, maximum amplitude is this, it will go only up to this particular point. This particle will go only up to this particular point. Again, this is stationary. So these particles, 1, 2, 3, 4, 5 in this diagram that I have drawn, would be stationary. And this particular wave would just appear to move up and down. We would not feel that the wave is moving forward. Right? So it gives the impression that the wave is stationary at one particular location, and therefore is known as stationary wave, right, or a standing wave. Right? These particular points where it appears as if they are not moving at all, they are known as the nodes. And these points where there is maximum displacement, right, these points, they are known as the antinodes. So this is how a standing wave is formed. The conditions required are the two waves which are superimposing onto each other should be identical, and they should be moving with same speed. And of course, they should be moving in a bounded medium. Bounded medium. So if these conditions are satisfied, what we come across or what we see is a stationary wave. Right? This is a very important concept from a real life application point of view. We come across stationary waves, whether it's a transverse wave or a longitudinal wave. For example, if we take the example of a flute, right? And the flute produces longitudinal stationary waves. There is an air column inside, and what we produce are longitudinal stationary waves. In case of string instruments, like for example a guitar, transverse stationary waves are produced. Right? So these are the real life applications of a stationary and standing waves. What I want you to do is that, you know, have a look at an animation, right? And an animation of a stationary wave. Once you look at an animation, you'll get an exact idea as to what exactly it means. I have made an effort over here to help you understand how this wave would look like, but in this case, I would strongly recommend that you have a look at an animation of a stationary wave. Compare it with a plane progressive wave, and then you'll be able to get a very good idea about what stationary waves are. Okay, with this, I'll end this video over here. In the next video, again on stationary waves, we'll look at the equation for a stationary wave and look at the math involved in stationary waves. Thank you.